This is a math walkthrough video on calculating rafters for an unequal pitched intersecting roof. Goes with level 4 carpentry. It'll be a fairly lengthy video. Obviously pause as you need if you want to walk through each section. The first thing we do is we look at the sheets we're given, and then we have these rafters numbered that they want you to calculate. But the way you should begin with these sheets is to separate the roof into 3 different portions and get yourself get a bunch of information that you need before you even begin looking at these numbers and figuring out what they might be. So you're always given a minimal amount of information. You're given building size. You're given a slope, which will be for the major portion of the roof. So this will be the slope of the major portion of this roof, and then you have the spacing per rafter and the projection all around the building being 600. Okay, so the way you should begin this is to calculate the major. Let's take a look here. So step 1, major roof. Let's figure out from that slope we were just given, we have a hypotenuse, so we have this for our major triangle. We can calculate our total run based on half the span. Well, you'll see the calculation says the total span plus the 2 projections divided by 2 gives you this run right here. That's what I've done here. And then all I did was, once I got the run, I just proportioned it off against our slope triangle to figure out these other dimensions. This 4943 would be the line length of the major common rafter. Okay, and then 3797.4 is the total rise of the roof, and that'll be the total rise of the roof no matter where you are, minor, major, or valley. They all share the same rise. They all extend to the same point. And then the last part of the major calculation should be the overhang itself. We know that the projection is 600, so again, in the exact same way that I've done this here. For the line length, we do the same thing for the overhang. We get a total line length of overhang of 937.2. Actually, and one more piece of the puzzle that you should get before moving on to the minor is the line length of the major common rafter to where it sits on the edge of the building. We can do this in a couple different ways. I've just taken this distance here, 5129 divided by 2. That's what that would be. And then I proportioned it off against any of these triangles. They're all the same difference. And then we have a line length of the major of 4006. So that's all the information we need to get started on the major. Let's do the exact same thing on the minor. The difference here being is we don't have a slope for the minor. We have to find that slope. We find that slope using the rise that we determined, the total rise, that 3797.4 we determined with the major roof. And we calculate the total run of the minor. So in the same way that we found out the run here, we find out the total run here by adding 4102 plus 2 projections divided by 2. It gives us that total run there. Here that is right there. That goes in hand with the rise. There you have the line length of the minor rafter, 4631. And exactly the same way we did for the major, we figure out the overhang triangle and we figure out the line length to the building edge triangle. And there you have all the numbers there, all calculated, all proportioned off against the same triangle that we have here. And the numbers on the framing square is good to get at this point as well because it's the same calculation. So we're going to keep it consistent and use 250 on the body of the framing square. So the blade of the framing square will be 358 as we proportion it off against our triangle. Okay, so now we have all the information we need for minor and major. Let's get to the valley. Okay, the valley being obviously the rafter that runs at an angle to the minors and the majors. And let's have a look at the valley. There's a couple different ways we can find this. Here you see I've calculated the run of the valley using the run of the minor and the run of the major, and turn that into a proportion triangle. Very much the same way we would do on a hip roof on a level 3 rafter calculations. Finding the total run, and then here I've taken that total run, proportioned it, I've put it in the same triangle as the total rise, 3797.4, and that gives us our total line length of the valley of 5609. Now that's one way we could do it. Another way we can do it is use the slant triangle. So this would be the triangle that's not in the horizontal dimension anymore. It's been brought up into the slope of the roof, where we use the line length of the major common and the minor run, and we will now proportion that off against we'll calculate the hypotenuse of those two numbers, and you notice that we get the same number here. I was just looking ahead to the valley overhang, so we can do the same for the overhang based on the overhang we calculated for the major. And if we proportion this off, the overhang off against this triangle here, we can find the actual length of the overhang for the valley is 1063. And now we can calculate the numbers on the framing square. We need to use this triangle up here, okay, the rise run triangle of the valley, to determine our numbers on the framing square. And in this case, we're taking the body length on the framing square as 354, which is similar to how we do the hip. The ratio of how we do the hip is kind of arbitrary, but we're using a larger number than we do the minor and the major commons. But you can see here we have the ratio of 326 on the rise compared to the 354 on the run. So we have our major, minor, and our valleys figured out now. Next step suggested here is to figure out the common difference in the valley jacks. So we'll start with the major. And you can see the common difference would be the difference in length as we creep up the valley rafter, and that's what we're calculating here, the line length, the common difference in line length of the major rafters. And we will proportion the spacing of 400 in this case off against our slant triangle for the major, which will be the minor run. Minor run gets proportioned off against the spacing, and then the line length of the major, which is 4943, will give us our answer for the common difference in each rafter. So after we do the math on that, we get 746. And we do the exact same thing for the minor. Let me show you how that looks. So we just figured out this common difference here for each of the majors, and now the same thing for the minors. We're going to figure out the common difference in length for the minors. We do that the exact same way, except for we're using the minor slant triangle. The minor slant triangle being a function of the major run, and then the line length of the minor. And then the spacing, which is 400, will be proportional to the major run. And that'll give us our difference in length of minor valley jacks. Okay, 585. Another piece of information that we should get before starting to calculate our rafter lengths is the distance to the corner for the seat cut on the valley. Okay, how do we do that? So if you can picture this as this is the projection of the building here. This would be the building line. Okay, we're going to use the triangle of the run and the run. So here we have the minor run and the major run. If I can show you through here. So if we take the minor run distance and the major run distance, and then proportion that off against a little chunk of the overhang. I don't know if that made much sense, but that's what we're doing here, using the projection as a proportion to the major run. So we figure out this little distance here, 503. So if you can see, that's what this triangle would be right here. So if our major and minor run come to the back corner here, we've just taken a triangle and made it, proportioned it off against here, right? So the projection here will be the 600, and this distance here will be x. And that's what we've just figured out there. So to figure out the distance from the building corner, all we need to do is take that projection, which is 600, and subtract the x, and that'll tell us how far from that building corner our valley is going to sit from the corner. And there's your answer, 97 mil. Another piece of information that'll be important to have for building this roof would be the difference in wall heights. Now, in order for everything to sit properly and evenly around the eaves of the house, we actually need to frame the walls of the minor roof a little bit higher than the walls of the major, and that has to do with the difference in rise of the two projections. So we take the rise of the minor overhang, which we found in, let's see here, the rise of the minor, let's go back up. Where's our minor? There's our minor roof. There's our rise, 859, rise of the minor. And then our rise up in the projection of the major. And let's get back to that. Here we have it, 139. So the minor walls will sit 139 mil higher than the major walls. Now we can actually get to filling out our rafter sheet. And you'll find, if you've started the way that I just showed you, which takes a while, gotten all those pieces of information, filling out of the rafter sheet is fairly straightforward. There's only a couple that you have to do some new calculations for. Let's see here. Step 7, fill out the rafter sheet. Now if we look at rafter number 1, we have all that information, and we'll just fill it out based on what we did for the major common. Okay, and that was above. Rafter number 2 is a major valley jack number 1. Okay. To find that, we need to figure out this distance from rafter number 2 to the peak. And in order for us to find this distance, we start where our layout began for the major roof. We're going to take this distance to the junction of the ridges, which will be the building jog 1701 plus half the 4102. And then we're going to subtract the number of spacings that we need to get to our rafter. In this case, it'll be 1, 2, 3 spacings. Let's take a look at the math. Find the distance. This is me explaining that. Minus the 3 spacings will give you the 2552. Once we get that horizontal distance, we're going to proportion that horizontal distance off against our major slant triangle, and that'll give us the line length of this rafter. And we get 4758. To figure out the overhang, we're going to take that 4758 and subtract the major common line length to the building edge, which you saw me do right at the beginning Remember, that's why I said it's handy to get all that information right away. There it is right there, 4006. Okay, so it's good to get all that early to make this part of the process easier when the time comes. And then we have here major valley jack number 1, with that line length, with that overhang, and then using the same numbers on the framing square. Major valley jack number 2 will be rafter number 3. And this is pretty simple. You've already calculated the common difference in major valley jacks. And this is where it's handy to put all this in up here as well. You get all that information, put it in here. All you need to do is take that 4758, subtract the difference in minor or major valley jacks, and there's your length of the major valley jack. And in the same way that we did this here, we're going to take that number, 4012, subtract 4006, distance to the building, and we get a overhang of 6 mil. Okay, let's keep going. And I explained a lot of it out in here if you really want to go through the details, but I'll try my best just to verbally explain it in the video, and you can walk through it on your own if you need to. Look here, number 4 is the minor common, which we've already calculated. We did that on sheet number 2. Here we have it, minor common. All the numbers already figured out. All I did was just punch them in from the math I did previously. Next one they want us to calculate is rafter number 5, which is done the exact same way as we found rafter number 2, except for this time we're coming from this layout here. And we're going to figure out the distance from the building edge, or the beginning of the layout of the minor, which is the building edge. The distance there to the junction of the ridges, minus the distance from the building layout to rafter number 5, which would be 1, 2, 3, 4, 5, 6, 7 spacings times 4. And if you look on the sheet, you'll see I've walked through the math here, sort of explaining all that. There's your 7 spacings times 4. And this time we're going to proportion that off against the minor slant triangle. And you see me doing that here, and we get the line length for that rafter of 4530. And the calculation of the overhang is done the same way, except for we're using all minor numbers, which you'll see on sheet number 2. Okay, and then you can see that after those numbers are figured out, we have 4530, we have an overhang length of 948, and then we're using the same numbers as we would for the minor common for the minor valley jacks. Number 6 will be the same way we found number 3. Once we find number 5, we have to get 5 to find 6, just like we had to get 2 to find 3. All we're going to do is use the common difference in minor jacks, which we figured out as well, and we put that in on our sheet. So we can actually just take that difference in minor valley jacks, 585. So we can take 4530, subtract 585, we get 3945. And then again, we'll take that distance from the edge of the building, the distance of the minor valley to the edge of the building, subtract that from here, and we get 363. Let's have a look. There's your total length there. Checking for the overhang now. We're going to take line length of that rafter minus the line length of the minor building to the building edge. Sorry. 3945 minus 3582, and there's your overhang length right there. Now we get to the valley, which we've already calculated. And all I've done on the sheet is punched in all the numbers from sheet number 3 of this math walkthrough for the valley. And there they are right there. Remember, we figured on the framing square we would use the 354 for the body, and then 326 for the blade. There's your valley rafter right there. 2 more rafters we're being asked to calculate now. They're asking us to number 8 and then number 9. Now these 2 are done in a very similar way to how we did 2 and 3. And we're going to start for our layout occurred. And this time we're going to count the number of spacings to rafter number 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rafter spacings times 4 will give us the distance to here. And then we're going to take our distance from our layout to the junction of the peaks and subtract it from that distance to number 8. And what we have left will be this distance here, which would just proportion off again against the minor or major slant triangle. Let's have a look at that. Okay, where are we? There we go. Major valley jack rafter. I haven't numbered it. You can number it if you want to, but as long as we know which one we're referring to. There's that distance, 16 spaces times the 400. Then the distance from the layout start to the ridge, 3752. The difference between those, 2648. There's your 2648. Proportioned off against your major slant triangle will give us the line length of the rafter, which ends up being 4937. So just 6 mil difference from a full rafter. And you can see here, I mean, it's really, really close, right? A lot of these are done to scale, so giving you an idea of how close it is, but we still need to calculate it for everything to work out properly. Once we have our line length for this rafter, we need to calculate that overhang in the same way that we've done all the other overhangs, minus that 4006, which would be the line length to the building edge of the major, gives us an overhang of 931. And we punch all that into our table here. And we have one more rafter to calculate, and we're just going to subtract the common difference in major valley jack 746 from this one, and we get 4191. And we're going to take 4191 and subtract 4006, which is the distance to the building, and we get 185 for an overhang. So these can seem a bit more complicated than they are if you have a good system, and if you get your base information down before you even get to calculating the rafters, it can be a lot less intimidating than it sometimes can seem. So again, start with calculating everything major. Everything major, which would be the line length of the total major rafter. Get your slope triangle all figured out. Get your overhang all figured out. And get your line length to the edge of the building figured out. Do the exact same for minor. And then do the exact same for major. And then, yeah, you should be on your way. Hopefully this helps you understand the math.